day, folks. This tutorial is about the linear buckling of a wind turbine tower using the 3D Experience release 2026X. Now, it's based on the paper that you see here, which was published a few years ago. But this paper is also used by Dr. Wagner here uh, to model it in the free software which is called PrePomax. Actually, there is a playlist that I have which is on doing linear buckling, or actually doing buckling with 3D Experience, that you can find it here. So the present video is going to go in there too. Now, here's the tower of a wind tower, which is appearing in that paper that I mentioned, and uh, the link that was shown on the first page too. It's made of, you can see here, 15 layers, 15 levels. And although the step file is available from Dr. Wagner's site, I decided to create the model. So it's just a few minutes, create the model from scratch and then move on. And my strategy for doing it is creating uh, these 14 planes. On them, draw circles of the appropriate diameter, and then do a multi-section surface to create the structure. The very top level is just the extrusion that is done by 600 millimeter at the very end. Don't worry about these points that you see at the very top and the bottom. We're gonna take care of those later on. Those are basically the places that we're gonna apply coupling and apply the boundary condition and things like that at those points. Don't worry about it. Now, here are the planes that I was talking about. There's 14 planes here, plus this very bottom one, which is actually the XY plane. And then on each one of them, I draw a circle of the appropriate diameter. And these diameters are given in the paper. And I'll show you here. Here are the diameters. And between any two circles, I do a multi-section surface. So it's just basically a surface between these uh, two consecutive circles. Now, the heights of the planes are here. So basically, the height of each layer is given there. So I'm going to be using those. This is actually coming from the website. The material assumed to be linear. Obviously, we're doing linear buckling, so all you need is the Young's modulus and Poisson ratio, and these are the values that are used in the paper. Now, as far as the loading is concerned, that paper considered two cases, load case 1 and load case 2. I will only do load case 2. In other words, the top, the top of this tower is subjected to 4 loads here, a vertically downward force, shear force Q, a moment in that direction, and a torsion in the vertical direction. There's also the weight of the structure that's going to come into the picture. So I'm going to be using only this load case. So we're going to do buckling for this particular loading condition. Now, what you see on the very top is actually coming from Max tutorial, and this is the actual paper that you see here. This is the part of the actual paper that I've copied. Okay, so these are the numbers that are referred in load case 2. Now, when it comes to meshing, each of these surfaces that I have created, and there's 14 of them, 15 including that top extrusion one, each one of them is going to create a mesh, and if you don't ask them to be merged together, at the interface, the nodes to be merged together, obviously they're not connected to each other. And you have to do some other trick, coupling, etc., to do it. But what I'm going to do when it comes to meshing, I'll start from the bottom all the way to the top, and every time I say merge any two nodes that are within 10 millimeters of each other. So first of all, I will be using parabolic element. The mesh size is 100 millimeter. Make sure that you check this thing so that the duplicate nodes or either duplicate nodes or nodes that are close by are merged 10 millimeter within 10 millimeter. Uh, and then I can assign different thicknesses because each of these layers have its own thickness. So this helps me to specify this process that I'm doing. It helps me to specify the uh, shelf thicknesses easily. And when it comes to buckling, the default maximum number of iteration is 30, but 30 may not give you good, reasonable, well, actually may crash. It needs more than that. I use 300, but try 200 if you want. Okay, so let's go ahead and do that. Just a couple of comments here. Uh, the thing is that if you import that step file from the link down here, Dr. Wagner's link, then you have to do a lot of massaging in order to separate these things because when it comes in, it's all one surface. It has to be cleaned up. That's why I decided to go and do this thing from scratch. Okay, before we actually go to the 3D experiences interface and model these things, you see on the left side, I have also indicated in the slide the thicknesses of these 14, 14 sections, levels that I have created. Now, the very top one, that extruded surface on the top, that's not a multi-section surface. Generally, this surface is just extruded. The thickness is 50 millimeters. Okay, let's go ahead and here is 3D experience. And I'm in part design right now, so let me go ahead and create my 14 planes. This is the XY plane, so I'm going to create 14 planes, and the distance between these planes is going to be coming from what you see there. Now I'm going to do just a couple of them, and then I stop the recording and I do the rest. And when I finish all the 14 of them, I come back and uh, start recording again. All right, let's go there. We go to essential. There's a plane here, and it's going to be offset from, I'm going to be using offset from the XY plane by the distance. If you go back to that slide, the distance or the first plane from the XY plane is actually 2,897 millimeter. So it's offset from this. The value is 2,897. Yep. Okay, let's fit it. That's the first plane. See, this is the XY plane. This is the first plane above it, which is a height of 2,897. And let me do one more for you. Offset from this. That is going to be distance of 2,368. 2,368. Yep. And then have to repeat the same for the remaining 11 or 12 planes. So what I'm going to do, I'm going to stop this, stop the recording, if I can find it. Okay, now that I have created these planes, I'm going to start drawing my circles on it. And what do I mean by circles? So at the very bottom one, I'm going to draw, this is the XY plane by the way, I'm going to draw a circle of diameter 5500. on the next one 5500, etc. So you keep going up and creating these circles. Notice that the very top one is the diameter is 4145. That's why it looks a little bit smaller than those. So I'm just going to do the first two or first three, and then I stop the recording, do the rest, and come back. Okay, let's go here. So on this horizontal plane, this is the XY plane, I will sketch, draw a circle, and the diameter of it is 5500. Okay, exit. There's my first circle. And of course, because the next circle has the same diameter, it is possible to project this circle on it and move on. But you know what? I'll just go ahead and do that. So on that plane, I will sketch another circle the same size. As I said, all you have to do was project that. That's okay. 5500. Exit. Here's the second circle. Let's do one more on that plane. I will sketch another circle, same diameter. Okay, exit. And I'll stop the video here, do the rest, and come back. Okay, this is the last circle, so I select that, sketch on it, draw a circle, diameter, and the diameter is 4145. 4145 millimeter. Enter. Exit. So what you see here are actually these circles. Now, I'm not going to bother doing these points right now yet. We'll come back and do that later. Okay, so let's see. Yeah, now we're going to create a multi-section surface between any of these two. That's a surface, so we can't do it in part design. So I'm going to switch to, for example, generative shape design. Okay, don't show me again. All right, now before I do that, let me do a quick save. Always a good idea. We are in generative shape design, and there is this icon on the surface tab. Right here is the surface tab, and there's this icon which says multi-section surface. You select it, and patiently, I will do a few of these, maybe the first two, and then I stop the video, go do the rest, and come back. Okay, so I want to do a multi-section between this curve and that curve. And because this is a very nice, well organized set of drawing, these closing points and everything are okay. Good. Let's do one more. Another one between that circle and this circle. Generally speaking, when you do multi-section surfaces, you have to make sure the closing points are close by, and then these arrows point in the same direction. But this is a fairly well organized thing that we did, so we don't have to worry about it. I'm going to stop this and do all of these, and maybe come back and do the last one for you again together. Okay, I did all of these except for this last one that we're going to do together. So click on multi-section surface, select this and select that, and then we say okay. Now that top flange is 600 millimeter. I'm going to do an extrusion, simple extrusion here. So let's go ahead here. Let me find the extrusion. This is extrusion right there. You can see that extrusion, and from here in the vertical direction 600 millimeter, and there is a top flange. Okay, so basically we have done the geometry. Now I'm going to do these points that I was talking about. Let's go ahead and create a point up there. So we go to wireframe. Here is a point, and we do it by selecting the center of a circle. I'm going to select that top circle. So a point is created right there. You can see that center of that, and then another one at the bottom. Later on, we're going to create a coupling between this point and the edge of that circle, and then apply our load. And down here for the constraint, so another point, again center of a circle, this bottom circle, and the point has been created there, and we're going to apply our clamp condition at the very bottom. There's a point there, you can see that. Okay, good. Let's do a quick save. All right. We will apply our material properties here. So let's go to tools. Let's go ahead and create one. And I'll call this thing steel wind turbine. Okay, we want the simulation domain to be checked, and it says the total number must be bigger than 0, whatever that thing means. So there, and then we say okay. And it's going to be created, so we're going to apply it and put our number in it in a minute. Just 1 second. All right, right there. So I'm going to say apply, close that, put it on this, and then we're going to put our number in there. Double click. Okay, so you're dealing with the structural general density. We need the density because the self-weight of the turbine is included as one of the loads. So based on the, I think I actually, oh yeah, it's right there. You can see that it is mentioned what the density is somewhere here, 7,850. 7,850, 7,850 kilogram per meter cube. And then we go to Abacus Multiphysics, mechanical, elasticity, elastic. This is 210, 210 gigapascal, 210 GPa, Poisson ratio 0.3. And I want to remind you that the FEA module buried inside of the 3D experience is actually the Abacus program. Now that paper, the original paper that I showed you the reference to, their calculation is also based on Abacus, but not the one in Dr. Wagner's tutorial. Okay, he's using that free software. And then we say, okay, good. Do a quick save. And we're good. We can now go and create a finite element model. So we go to, first we have to go and mesh it. Structure model creation right there. Structure model creation. And because we're going to do the meshing ourselves, I'm going to say empty FEM, because otherwise it uses a default shell element that is. We're going to use eight noded parabolic elements. Good. Okay, so here's what we're going to do. First, I can do the meshing and apply section property, or do all the meshing and then come back and do section properties. It's entirely up to you. Maybe it's easier if I did it simultaneously. So we're going to go to mesh. Here is surface quad mesh. You click on it. You select that surface. Now here's a parabolic. That's already checked. I want to make the mesh size 100 millimeter. And notice that this first one says also capture any nodes that you see within I'm going to change that to 10 millimeter. It says capture any node which is within 10 millimeter of your cell. Well, there are none here. So that first one doesn't matter whether this is checked or not. It really doesn't matter, but I've checked it because I knew that needed later on. And don't forget to say the mesh. See that? Mesh. Good. And then we say OK. Now, we can apply our section property right there or mesh all of these and come back and do it. I rather do it at the same time. I will do maybe 2 or 3 of these and then we come back, okay? So let me go ahead and go to properties. Here is section, shell section. You select this, automatically the proper material is selected, and this particular one has a thickness of 17 millimeter. If you go back to the slide, 17 millimeters, right? Say okay. Good. Now, what slide am I talking about? I'm talking about, where is this? These thicknesses, see that? Let me do maybe one more, and then I do the rest, and I come back, and we'll worry about the top one, do it together. Okay, let's do one more. So go back to mesh. There we are, surface mesh. These numbers we're not going to change. Now, it is important that we have this thing checked. That's why if it sees any node within 10 millimeter of it, it's going to get merged with that. But everything is okay here. So we say mesh, and then we say okay. Incidentally, you see that, well, at least here it may be obvious, but we're going to check that later on. Now the property, shell section. On that, this one is actually based on my slide. It is 16 millimeter. Okay, so let's go back here. This one is going to be 16 millimeter, and then we say okay. Now you get the picture. You do all of these, and then we're going to come back and worry about the top one. So I'm going to stop the recording here. Okay, let's go ahead and do this last two. So I'm going to go to mesh, surface quad mesh, select that. Everything is okay here. Mesh, and then we say okay. We go to properties, shell section, select what I just meshed, and this one has a thickness of 13 millimeter. 13 millimeter. And the last one is the extruded surface, so no problem. Go to mesh, quad mesh, select this, mesh it, and we say okay. Go to properties, shell section, select this last one that you did, and this last one is 50 millimeter. 50 millimeter, and then we say okay. All right, now if you look close enough, you see that all the nodes are actually matching. The reason is that we checked that thing and there is no issue. Now, another way to check this is, first of all, let me save this. If you go to display, just a second. Okay, if you go to display, there is this icon here. It says numbering visualization. You say okay, no problem. Say update. Okay. Give it a minute. Okay, good. If we click on this, which says numbering visualization, and if you zoom in, This was the seam line. If you come from the top, notice that this number is 1598.46. If you go from the bottom, 1598.46. If you go to another, for example, seam, let's say this seam, if you come from the top, it says 1490.90.15. If you come from the bottom, 1490.15. If you look at this, for example, it's the mid-side node, 1491.40 something, and you go from the top, 1491.48. That's because we merged anything which is 10 millimeter of each other. And then we say, okay, good, close that. Now, while we are at it, we can create those couplings. So notice that there is this connections here, and we can say coupling, click coupling. So this, let's go and do the bottom one first. Maybe I'll do the top one. It really doesn't matter. Okay. Look at what it said. Okay. Coupling between that point, there's my point, there's my point. Okay. And for support 2, I select this edge. And I'm going to make it kinematic coupling. All degrees of freedom are matching. That's fine. And do another one. So do another one for the bottom. So I'm going to do the second coupling. Here's the coupling. I'm going to select this, try to select this point, no problem. It picked it at the very bottom. But when I try to select the edge here for this, see that for the support 2, it won't take it. That's because there's a sketch here that is actually hiding the bottom circle. So let me put the cursor there. Say hide. So the sketch goes away. Now I can select this edge. See, that sketch was sitting on top of this bottom edge, and that's why it will not let me pick it. But now it will. And I'm going to go to, again, kinematic, all degrees of freedom, and then we say, OK. So here is our couplings that I've created. This one for the top one, this is for the bottom one. Later on, we're going to clamp this and apply the load on the very top. Okay, here is the tower, and first of all, if there are things that are blocking your view, you can always hide them. There's a lot of planes here. For example, I can go on hide. If I go to part body, all these planes, I see all these planes from here, shift to there, you can hide. There we are. There are sketches here that you can hide. So if I go to sketch from here to there, I can hide. There we are. If you don't want to see the actual mesh, so let's get the visualization manager, visibility manager, and let's hide the mesh. These are actually the surfaces you can see. So maybe just leave it the way it is. All right, good, good. So let's move on. We are done with the creation of the model and meshing. So we're going to go to mechanical scenario creation, either this or structural scenario creation or structural scenario creation. I go to this because this is the glorified version of structural scenario creation. Click on that. Okay, just wait for it to come. Very good. First of all, we are doing a structural problem. I'm going to use the structural. We already have a finite element model here. We select that, and then we say, OK. Good. Once again, I don't want to see this mesh, so I'm going to use the visibility manager to hide the mesh. There. I want to make sure that this is actually being recording. It is recording. Very good. Okay, so procedure. Procedure, I'm going to do buckling right there. Buckling step. Buckling step. This is linear buckling. Click on it. This thing pops up. And I already told you that I'm going to change this thing. I can leave it like 30, but there's a chance that it comes back that it says there's not enough iteration steps. So I'll make it 300. That's okay. You say, fine. Now, we're going to apply our boundary condition. So you go to boundary condition, you go to clamp, and remember we created these couplings here. Where are the couplings? Let's make sure that we have it. This is the bottom. See that? This is the bottom. You select that. That coupling says that that node, reference node, and anything that's associated with it is clamped, which is exactly what we want. We say fine. Now on the top for load, first of all we need gravity. You click on the gravity. Here's the load tab. Gravity downward minus 9.81. That's good. Now on the top, I can put all of these conditions simultaneously in one dialog box, but I prefer if I do 4 of them. 1, 2, 3, 4. Okay, 1, 2, 3, 4. Because for each of them, I can see separately what's going on. Although it's possible to put all these 4 in the same dialog box. But here's what I'm going to do. Let me go back here. Under load, this is concentrated load. Okay. First one, let me just give it. How about V? V concentrated load. V concentrated load. Okay. Now that is downward in the direction Z. It's 44. Let me see now. What was that? It was 4 meganewton. Okay. So I'm going to make. I'm going to put down here 4 minus 4. 1, 2, 3, 4, 5, 6. That's meganewton. And then we say OK. Because, oh, I forgot to select, sorry. I forgot to select the actual, where is that thing? This thing. I forgot to select the support. The support is that coupling one on the top. You can see that? You can see this thing nicely. Now, let's do another one. The other one, we're going to do it for, how about Q? And Q is 1.6, okay. So we do another one, just so that I can see it, on that same coupling, in the direction Y, 1 point, what was the value? 1.6 meganewtons. So it's going to be 16. 1, 2, 3, 4, 5. Is that 1.6? Yeah, 1.6 meganewton. 1.6 meganewton, 5 zeros and a zero. Say OK. There, you can see that. You can easily see it. If you put it together, it's going to be a tilted, vector. It's kind of hard to see. But I don't remember whether I put the label there. See that? This one, I'm going to call it Q so that I can read it easier later on if needed. This is the Q. Okay, good. Another one is the torsion. Torsion in the vertical direction. So let's do another one. I'll call it T torsion, TT. Did I call it T or TT? It really doesn't matter. Yeah, T actually, TT. Okay, that's about the Z direction. And let's see what it is. It is 22 meganewton. So we go back here. I put down 22. 1, 2, 3, 4, 5, 6. Okay, and the support is that the same coupling one, and then we say okay. See that? There it is, right there. And finally, another one, which is our M, I believe. What do we call this thing? The other one is M. Yeah, M. Okay, so we go here. Another one on that same coupling. In the direction, we want it this way, so it's going to be negative, the direction X, negative 22, 1, 2, 3, 4, 5, 6. Yeah, 2, 3, 4, 5, 6. Yeah, that's good. Yeah, that's the one right there. Oh, put it in the wrong spot. Sorry. Let's go back here. That's 0. In the momentum direction X, right there. Let me clean this. In the direction X, negative 2, 2, 1, 2, 3, 4, 5, 6. Let's check it out. That is not the correct direction. Oh yeah, it is. It's like that. Very good. And maybe I should have called this thing also M, right? Very good. I think we have taken care of everything. Let's do a quick save. All right. And that's pretty much it. So let's go to simulate. First, we do a model and scenario check. Okay, that's good. Then I do a simulation check. Okay. All right. Now later on, when we try to run it, this could take as long as 10-15 minutes. So what I'm going to 10 minutes, and I have a very cheap computer. I mean, this is nothing crazy. So it might take about, and we are doing it offline, by the way, offline on the cloud. Okay, it may take about 10 minutes. So what I'm going to do, I will cut the duration that actually it's doing the calculation, but I will report to you how long it took. This is done. The biggest problem is right now when we try to run it, simulate. This could take 5-10 minutes, depending on how fine a mesh you've got and what your speed of communication is, whether you lost your connection with with internet, etc., which I hope I don't. So, but I'm going to run it, but I'll cut the so many minutes in the middle and then tell you how long it took. Right now it's 10:10 a.m. Look, it's extracting the results, and it's 10:14. So it took about maybe 4 minutes. Not bad. See that on the very top? It says extracting result. That's it. So 4 minutes. That's a lot of nodes and elements that you got here. So let me close this. There we are. So if you look at the displacement, these are the different uh, buckling state, and these are the buckling factor. You can see that this one is 1.4, and if you go to the paper, if you go to the paper, which let me get the paper for you. Not there. Uh, so if you go to the paper and scroll down until you come across the formation right there, you see this right there, 1.401. And what you got here is, let me go back there, 1.44-ish, okay? And that's the other mode. This is the second mode, 1.5, 1.5, okay? So yep, it's pretty close. If you eliminate those torsion, that torsion and moment, and you run it, you're going to come very close to these numbers. By the way, these are the same thing that the Wagner is getting. All right, good luck.